All right, so our first example here of graphing a rational function. I've just got those the four main characteristics that we're going to look for, the two intercepts and the two asymptotes. So, just as a reminder of those steps on the previous page. For the y-intercept, that is where the graph crosses the y-axis. So that is where the function has 0 for the x value. So we plug in 0 for x and simply see what we get. That'll be a 0, that'll be a -1 over -1, which is 1, which means we plugged in 0, we got out 1, so our y-intercept is the point, 0, 1. For the x-intercept, we said, happens when the function equals 0, but when you have a fraction, that's really just talking about the numerator. So the numerator there of 2x minus 1, and setting that equal to 0, solving that simple linear equation, I would add the 1 over divide by 2 and get 1/2. So x equals 1/2 happening when y equals 0, giving us the point 1/2, 0. For the vertical asymptotes, he said those occur when the denominator is 0. Those are the places we have domain issues, right? So our denominator there of x minus 1, setting that equal to 0, that happens when x equals 1. And as we saw, that is actually the equation of the vertical line. So the vertical asymptote, the only one we'd have on this graph, is the line of x equals 1. For horizontal asymptote, remember that comes strictly from looking at the lead terms of both the numerator and denominator. Now, since they are both x to the firsts, right, when we go to find the horizontal asymptote, we actually will then need to use the ratio of those lead coefficients. So since these are both x to the first and in a match, we need this 2 over 1, which would be a 2. And so our horizontal asymptote will be the horizontal line of y equals 2. And now the question of does it cross, that again comes from taking the function and essentially asking the question, this function of 2x minus 1 over x minus 1, will it ever equal 2? Will it ever equal the y value of your asymptote? Because again, that's that horizontal line, and we're asking, does this ever have a point? Does it ever have a point on that line? So we will always clear out the denominator first, multiplying both sides by x minus 1. So we have 2x minus 1 over here, 2x minus 2 over there. And in solving this linear equation, the next step would be to move or subtract that 2x from both sides, but that cancels on both sides, leaving us with -1 equals -2. And so again, we're left with what I could call a special case where variables are gone. More importantly, we're left with an equation that doesn't make sense. This is never going to happen, which means our original equation that we're trying to solve for is never going to happen. Meaning the question to, will our graph cross this line? The answer is simply no. All right, so those are the four key characteristics. Now something else that's mentioned again on the steps on the previous page, the idea of finding additional points. That's certainly something you can do as we go to a graph here in a moment. But also I do want to just mention the multiplicity information, which was multiplicity of both x-intercepts and vertical asymptotes. Notice this x-intercept came from a linear factor, so there's only one of it. So this is, if anything, a multiplicity 1, and I'll even put that right here, multiplicity 1, meaning again, this 0 came from this numerator, which was just that factor, no powers of that factor, so multiplicity of 1. Same with this vertical asymptote. It came from the denominator. And when we set that equation equal to 0, that is a single factor, x minus 1. So that vertical asymptote also is having multiplicity of 1. So that will be useful information regarding the whole bouncing and crossing or opposite infinities and same infinities here in a moment. But what we'll do first is we'll take those 2 points and those 2 lines and we'll get them graphed on our graph right down here. So we have the y-intercept of 0, 1, that point right there. We will do our best to estimate the point of 1/2, 0 for our x-intercept. we have a vertical asymptote of x equals 1. So I'm going to draw the little dashed vertical line there. And we have the horizontal asymptote of y equals 2 that we'll draw in there. Now, we have these 2 points. And when we're graphing a graph of any function, the main thing to remember is being a function means it passes the thing called the vertical line test, meaning anything we draw, any graph we put on here, can never be crossed by a vertical line at more than one spot. So essentially think of it as when you start drawing a graph, you gotta go from left to right. You cannot double back around. You can never draw 2 lines under each other. That defeats, it does not follow the rule of being a function and passing the vertical line test. So we have these 2 points here, and we definitely can see they're gonna connect to each other. Now that means I'm taking that from this point here to this point here, and it's going to the left. If I'm going to the left, I'll continue going to the left, but I've got this horizontal asymptote to watch out for. And as we saw a moment ago, I know that my graph does not cross it. So coming from this point through this point, really my only option is to start asymptoting, getting closer and closer to this line, but never crossing it. And that's going to be its behavior going off to the left. And we talked about that too. The idea of any horizontal asymptote is giving you this kind of end behavior of where this function will be heading towards whenever x goes to both positive and negative infinity. So on this side, as you go left, as x goes to negative infinity, our graph is getting close to this 2, right? This horizontal asymptote. Coming back to this point though, this is an x-intercept, which, as we mentioned, was an x-intercept of multiplicity 1. And we learned this earlier in the chapter, that multiplicity 1, or any odd multiplicity specifically, means it's going to cross the x-axis. And multiplicity 1, we said it was a straight through. So from this point, it goes straight through it. But if it's going straight through that x-axis, we've got our vertical asymptote right here, and it has to asymptote going downward. So here is our vertical asymptote of x equals 1, and we have this guy going down to, call it negative infinity. Now, here's where we say this whole left side, everything left of that, excuse me, vertical asymptote is done. There's nothing else to graph. That is the entire picture of our graph left of this asymptote. Now, the question of what happens to the right, we have no information, right? We have absolutely no points whatsoever. Well, a couple things I'll point out, and these are general things you can always kind of keep an eye on. We have no x-intercepts at all, right? We have no information about x-intercepts over here. We have no information about points where it might cross the horizontal asymptote over here. But what we do have is the multiplicity of the vertical asymptote. So this would be a place where you could throw in a 2 or a 3 or whatever into your function and see what you get. Just find a random point. But I'm going to show you you don't even need to do that, because with the multiplicity of this asymptote, again, it was another single multiplicity of 1, odd multiplicity, and we said odd multiplicities for vertical asymptotes meant opposite infinities. And what that means is once you've got this drawn right here, you know this is going to negative infinity, going down on the left side of this vertical asymptote. You know for a fact that on the other side of this asymptote, it is coming from up top or going to positive infinity. That has to be true for any vertical asymptote with any odd multiplicity. And with that said, knowing it comes down from there, knowing it does not cross this horizontal asymptote, at this point, I'm going to say you can just sketch it. I don't need you to be super accurate. The idea is we know it is completely relegated, completely stuck in this top right corner. That's it. That is, an estimate. I'm not saying I know the point 2, 4 exists for sure. I'm definitely allowing you to have flexibility and to say this would be the area, this would be the pattern that we'd expect to see for our basically second half, right? Everything right of the vertical asymptote. And that's one way to think about it. When you're drawing these things, some are a little more complex than others, but always think of it as the vertical asymptotes are kind of like breaking your graph into pieces. So if you've got one vertical asymptote, you're gonna have 2 pieces. If you've got 2 vertical asymptotes, you're gonna have the left, the middle, the right, 3 pieces. But always make sure you're drawing your graphs as if they're going from left to right, never doubling back on themselves and never just kind of stopping out of nowhere. They're always going to be doing some form of asymptoting to the horizontal and or vertical asymptotes.